Hello students, let's begin handwritten exercise set for chapter 9, problem 1. Here we go. A radar unit is used to measure the speed of automobiles on the expressway during the rush hour traffic. The observer measures the speed of randomly selected 76 cars and obtains the mean speed of 62 miles per hour, 62.0 miles per hour. Under this assumption, we have to answer these questions, and here's the first problem. Assuming the standard deviation is about 4.95 miles per hour, find the 95% confidence interval of the mean speed of the cars. Now, before starting this problem, do you recognize this problem from exercise set for chapter 7? Similar setting, presumably the same expressway, same radar unit, and the same mean of 62 miles per hour. But there are a couple of big differences. Here, the speed of individual automobiles are assumed to be normally distributed, assumed to be, with a real mean of 62 miles per hour. Here in chapter 9, we don't know the real mean, and this is far more realistic. We got 62.0 miles per hour by observing randomly selected 76 cars. So this value here is not a parameter. It's a statistic. This is something we got from the sample, and we want to find out the parameter. Of course, we cannot find out precisely. We want to find out appropriate interval here. So that is one of the two main differences between the two problems. We don't know the mean speed here of the real mean speed. Here, let's assume the mean is 62. Difference number 2. Here, we are considering individual automobiles. Here, randomly selected 76 cars. So those are two big differences. Remember those two, and let's go to the problem. Assuming the standard deviation is about 4.95, find the 95% confidence interval of the mean speed of the cars. Here's the initial picture. As usual, we follow this procedure. Outline, center, end, and shade. Outline, okay, we have a normal picture. And then the center, what do you think that is? Observed mean is 62, so that's what you're gonna get at the center. And here we go, 62.0. That's the best point prediction, but then again, nothing is accurate in statistics. So you're gonna have some give or take, margin of error, so we are looking for some interval estimation, the green part. And we want 95% confidence interval. So I want 95% of the probability that the real mean falls here in the green part. I'm running my mouse around that green part. Do you see? And then outside we have this blue part. Too small, so I'm going to cut those away. And here, too large, so I'm going to cut those away. 2.5% and 2.5%, so that the middle is 95%. Does it make sense? The total has to be 100%, and it has to be symmetric. So here we go. One more thing about symmetry. Distance from the center here, 62, to the left-hand side end or right end, that distance must be the same because of the symmetry. And the maximum difference here is called the margin of the error. Anyway, that's the picture, and we are ready. We have the picture. Okay. Now, let's find out the z-score and get these x values. Ready? Okay, here we go. As usual, z is end minus center over SE. And this is a general formula. Previously, we used to do SD in the previous chapter, but that was just for one chapter. From now on, it's going to be SE. Whenever we have sample study, it's going to be SE. No, not this one. Okay, that's a little bit better. Okay, we have end, and we have two endpoints. Left-hand side endpoint is what I'm going to select. And then divided by, what is the standard error? Standard deviation is considered to be 4.95. So standard error is standard deviation 4.95 over square root of n, which is, in this case, 76. Do you recognize? 76 cars. As a matter of fact, let me take one more step. X minus mu over sigma over square root of n. Let's keep it like that. Ooh, what's happening here? Okay, that's better. And then x1 is the quantity we don't know and we have to find out. And then this whole thing has to be associated to the 95% confidence level. So in order to have the 95% in the middle, I need 2.5% here to the left and 2.5 here to the right. On the left, 2.5%, and let's see what z-score do I have associated to 2.5%. Here's a z-table. Here's a z-table. And let's look for 2.5% here. 0.025. Right here. So negative 1.9 row and 06 columns. So negative 1.96. So this had better be negative 1.96. And from here, you can find out what x1 value we're looking for. So let's solve this equation. Not too bad. First, flip this denominator to the other side. Times this one to the other side. And then I can flip this one over to the other side. I guess that's it. That's the computation I'll have to do. And you can punch those into calculator, but then again, I'd like to save my time. I'm just using Mathematica for that kind of computation, and this is what I'm going to get. So 60.887, that goes right here in the left-hand side endpoint. Okay, one down, one more to go. Because we want an interval, I'm going to start from here and then end over there. Let's look for x2. How do we find out? We can go all the way back here and then find out the z-score associated to 97.5% because 95% here, 2.5% here, so add them up, 97.5%. And then do everything, but who has time for that? Let's use symmetry. X is 62 minus of that from the center, subtract, and you're going to get x1. I'm going the other way around, so I'll have to just add, and that's going to give me x2, the right-hand side. So the plus x2, and that's plus, and ooh, what did I do? Okay. And then, of course, this quantity is not going to be 60.8871. Let's calculate this quantity. and it is 63 point something. So what did I get? 60.88 here, 63.11 from there. The confidence interval is, well, I have to say approximate. Nothing is accurate in statistics. And open interval 60.89. And then 63.11. Let's put more space in between. And I'll say this is the confidence interval. And if you don't like brackets here, you can use parentheses if you want to. It doesn't matter which interval notation you use. In any case, start from the left-hand side endpoint and end it at the right-hand side endpoint. And we have 95% of the probability that real mean will fall in between these two. 60.89 and 63.11, approximately speaking. Now there's 5% of chance that I'm going to fail, either too low or too high. I'm going to take that chance and then go with this. After all, I want 95% confidence level. If I want higher confidence level, then I'll select bigger interval. Here's the same solution there with a little bit more explanations. Same answer as before, and then same idea, symmetry. This minus becomes plus. That's the difference. You can see it clearly if you draw the picture. If you don't draw the picture, in the homeworks, I'm not going to take any point, but in the exams, you're going to be required to draw the picture because I really emphasize this picture. And if you don't do the picture, then nothing really makes sense theoretically. It becomes just a procedure which you're going to immediately forget right after the exam. And what's the point?